Hello everyone. In this video, I'm going to show you an introduction to prismatic machining in CATIA. So here I have made this part, which has basically a profile cut, right? So these fillets, you have to do a profile machining for them. And these holes, you have to first create the center drill, and then you drill them all the way down, and then you have a pocket here. And the stock that, let's say, I have to create this part, I have created a separate body part for it under part 1, and that is bigger than my actual part in all 3 directions. Okay, so I need to also do some facing on the top surface to make the thickness equal to the part. So I have several machining operations that I need to do with a prismatic mill, with a 3-axis mill basically. So as you can see, I created both the part and the stock in the same object using insert body, and then I made the stock transparent. Now I go to start, I go to machining, and I go to prismatic machining. So you see there are different machining workbenches here, and I'm gonna go to the prismatic machining, which is what I need. And then here, if you go under part operation, you see the manufacturing program and then the machining process list. And here under product 1, you of course have what? You of course have the part, and then here is the resources list, basically the physical parts. So the first thing I do, I double click on the part operation 1, and here it allows me to define my machine. So I click here, and there are different machines here. So this is 3-axis, this is 3-axis with rotary table, which is basically like a 4-axis. Here is 5-axis, here is the horizontal lathe, vertical lathe, and multi-slide lathe. So here I go with the 3-axis machine, and here you can define a tool change point up here, right? And that location you determine based on the physical system. Here, since I don't have a physical system, I just let that dimension be. Here you have a tools catalog, right? And you can choose from a catalog if you have a catalog specifically, or you know what tools are in each one of them. So here I'm gonna go and select them during the operations that I will add, so I'm okay with that. And then numerical control here, the dimensions for me are all in inches. So here, this post-processor word table, instead of using centimeters, right? So I go here and choose this guy, which is sample inches, okay? And I okay that, so my machine is good. Then I create my reference machining system, coordinate system here, and I can select planes, or I can select the origin, which basically comes with the planes as well. Then let's say I put it here on this point right on the object if I can. So let's do it again, click here and then go right at that point, and there we go. Right, and I okay that. Then you need to define your part and the stock. So here I click on the part, and then go here, double click on the part, then go to stock and double click on the stock. So they're there. If there is a safety plane you want to define, you can define that. If there is fixture or anything, for now I'm good. So I don't want to define any extra thing, so I okay that. And that means what? That means I have defined the machine and the stock and the part, right, and the coordinate frame here. And now under manufacturing operation here, there is nothing, but I can go ahead and add the processes one by one. So the machining in CATIA is different than SolidWorks. In SolidWorks, you see there is a command that it will detect all of the machinable features for you and generate the toolpath and then simulate it, and it's very simple and very fast. In CATIA, it's a little bit more complicated. You have to add those processes by yourself, and you have to kind of really know well what you need to do. So you need to know about the machining if you want to work with this environment, right? And you have to know some good amount of details. In SolidWorks, it's much more simplified for you. So here let's say the first operation I need to do is to reduce the thickness here of the stock and bring it down to the thickness of the part, and I need to do some facing basically. So what I will do is I click here, this is my machining operations, and I click here on facing, and I click on manufacturing operation program, and it brings this window for me for facing. And there are 5 tabs. One is the strategy, the other one are the surfaces, the other ones are the tools, the other one is basically the feed rate and stuff, the speeds, and then macros if you need macros. So here is the strategy. What is it? How you are going to do this facing, right? Here it's inward helical, and you can choose it to go back and forth, or you can choose it to go one way, right? So it is up to you how you want to get this done. And then the other things you can do is, let's say I go with one-way operation, right? Or as I said, I can do with inward helical. And then here you need to define the surfaces, right? So here is the top surface of the object. So for that reason, I'm going to go and hide the stock that I don't need anymore. So I just hide this, and then I need to define the top surface of, I click on that red surface and I click on the top surface, and you see that the part is green and this light is green. Any light that is green means that tab is good to go. If it's red means you have to define the information. If it's yellow means I cannot do it. It's a warning and you have to go and change the information here. And here you can have again some basically offset here, and you can have some check element which we don't need right now, so this is good to go. And then here is the tool, and you see the tool here is the end mill, while here we really need a face mill to do the facing, so we choose the face mill. And then here is, these are all the dimensions for it, right? And we can double click and change them, right, as you can see, or we can go to more here, and then it brings all of the information that you have for that face mill, and you can change everything here from the nominal diameter to the corner radius to the length to the cutting tool and so on, and make sure this is exactly matching what your actual tool that you have in your CNC mill. Okay, so here I'm not going to change it because I don't have a physical mill at my disposal right now, but you need to make sure these dimensions are exactly matching what the tools that you have, or you need to create those catalogs and you choose your tools from the catalog here, right? And then there are feeds and rates here, so there are all sorts of speeds. Now most of the speeds here we can determine under the third tab, right? And you see here they are computed from tooling feeds and speeds, right? There is approach speed, there is machining speed, retract speed, right? And machining for angles and so on. Again, these need to be determined based on the material that you have. Material is the #1 factor in determining the speed of the operation, and also the speed of the spindle and the size of the tool and how much material you are cutting. They all need to be physically exactly determined, so they are not just randomly selected. But again, here my goal is not to go over calculating those speeds exactly. It's a separate topic of its own, so I just leave it as is. And then these macros are if you want to control how the tool is approaching the part, how it is retracting from the part, the clearance from the part. Return is in processes that are one way, so you go and then return and then go again, right? So in one-way motions, these returns are important, and they are all inactivated, so you can right click on them and activate them, and then you have to specify all of the parameters for them, right? So if you activate this approach right here, and then how you're approaching this workpiece here, right? For example, you can say, I want to add an axial motion up to a plane or something like that, right? Or I want to do perpendicular to a plane, or I want to have motion to a line or anything like that, you can go ahead and specify them, and with these guys you can clean if anything is existing. So right now I don't want to do those macros, which are basically subroutines programs that you need to specify. So here my goal is to go over a simple introduction, so I'm not going to go over that part, right? So my goal is absolutely not to go over that. Okay, so we deactivate that and we don't need anything from there. And then one thing I can do is here I go to this animation, toolpath replay, and here I can play this, right? And it shows that inward spiral, right? But if you want to see the material removed, you click on this camera icon, okay, which shows you the stock material like this, and then go ahead and play it. There we go. You see? So it shows you how the material is removed. So now that we have done the facing, let's go ahead and add the rest of them. So for example, we can do this pocket here, right? Or we can do these drills. So let's go ahead and do the drilling. So here I click on the last operation I did, facing, and then I want to first do the center of the drills and then the drilling itself. So I go here and then I go for what? For spot drilling to locate the center of the holes. So click here and now this will be added. So here you need to provide the top surface of the drill holes, which is this guy. Now, one of the things is if you click here and then that window is gone, and you might wonder, okay, how do I get that window back? Just okay here, right? Or double click on that blank area, it comes back. Then you need here the surfaces of the drill holes, and you can just select the edges. So let's go ahead and select all of these 4 edges, right? And you see double click here, it comes back. And it extracts that diameter from the diameter of the holes, which is 1/2 inch. And then you need to say how far it goes down. So you double click here and say, let's say, for example, 0.2 inches or so go down a little bit, and leave a mark for the center of what? The drill bit, to drill it all the way down here. Okay? And so the surface is determined. And then we need the tool, and the tools here, you see there are different tools. For example, this is multi-diameter drill that we don't want. This is center drill, this is spot drill, right? And let's say we want to do spot drill, so we choose that, and this is good to go. So let's say we want to see the tool path, right? So here does the first operation, and then what? The next operations here, right? And you see these 1/2 inch diameters. Now typically when you do center drill, you don't want the diameter of the drill bit to be exactly the same as the final diameter. So one of the things you might have to change here is when you go to this tool here and go to more, you want to make sure that this diameter of the drill bit is a little bit smaller, right? So let's say I go with a 1/4 inch drill bit, not with the 1/2 inch drill bit, okay? And then let's do it again. There we go. This is more reasonable. You okay that, and you okay this, and now the center drills or the spot drills are there. Now I want to do the drilling all the way down, so I click on the last operation, the spot drill, and now I go here under drilling. This is the regular drilling, and this is for drill deep holes, which go all the way down. So I choose this guy. And then you need, first of all, it says, do you want it blind, or do you want to go all the way down? So you can click here and make it true, so it goes all the way down. And then you need the top surface here, which is this guy. And then you need the surface of the walls, which again are these 4 edges. And then you need the bottom here, which is basically what this guy here. So now it is good to go in terms of geometry. but you need to provide the tool, and the tool here is the drill itself, and you need to make sure that the dimension of the drill bit is correct. So you see here you can have a smaller drill bit, or you can have the exact size, which is half, right? So I might go with 1/2 inch drill bit, right? And this length here, that LC, should definitely be smaller than the depth of the part, which is 0.9 here. So that guy is good for me. And let's see what happens if I drill. So if I go here and animate it here, and then it starts drilling the 1/2 inch holes down. Now we'll see if it cuts all the way down or it doesn't. Okay, so it is going down, right? That kind of shows it like it's a vibrating up and down. You know, that's not the case. It's steadily going down and spinning. So the animation is not perfect, and you see that it doesn't cut all the way through, and it leaves that cone of 120 degrees at the very bottom. Okay, so it doesn't cut all the way through, although it is selected as true. It doesn't do the perfect job here, and that is because of this 120 degree angle. Okay, so if you make that 0 and make it flat like that, and let's do it one more time, then it should be able to go all the way down. Or you need some offset from the bottom plane, so it drills all the way and make the holes. Okay. Now, drilling, really, the tip bit is not flat. That is going to be a mill. It's not a drill. If it's what? If it's flat. So you see, it does the job, right? But it's not really what happens in reality. So you want this angle here to be what? To be 120. Okay, but when you go here, if you can provide some offset with respect to here, that is going to do the job. But if you can see here, there is no offset for the bottom plane. Okay, there is offset on the check, but there is no offset what? All the way down and below the bottom surface. So that is not going to do the perfect cutting, and that's why I basically created this angle to be 0 or 180, and that will do that cutting all the way down. Now that you have that cut, then the next operation is going to be creating this pocket. So I select that, and then I go to pockets, and now it is time to select the pockets. Now, one of the important thing is here you say if it's a closed pocket and it's a closed contour, right? There are walls around it. So you change this to closed pocket. Then here I choose the bottom surface of that pocket, right here, and that's this guy. And then I need the top surface, and that's this one. And you can choose an island, the walls of island. If there is something that you have to leave inside, you can choose a start point. And the next thing is you choose the end mill for this, and make sure that the end mill is small. Really, don't go with the big end mill. It has to be quite a bit smaller than this radius here, right? The diameter of it. And so for that reason, I choose my mill a little bit smaller in this case. And so I can get the geometry that I want. And let's see here if I can generate that tool. So the drilling are done. I fast forwarded a little bit for you. And here we go. Look. Perfect. So now the pocket is also done. And now that I got my pocket done, the last step to do is to do this profile, right? Basically create these arcs here. So now I choose my last operation, which is the pocketing, and you see I did it with the outward helical. I could do inward helical or anything I want, but as I said, some operations are way, like here, back and forth is really not a good operation, because you need to go around and repeat this operation. Also not backward forward, because you have these arcs. So this helical outward inward is really the good operation here. So now I choose my pocketing, and now I do the last part, which is contouring. So here I choose the profile contouring, and here I need this surface here. So that's the bottom surface. So click there and go and select the bottom surface. And you need also the top surface, and here's the top surface. And seems like it also needs this, let's see, yeah, no. Just selecting the bottom surface should be enough to select the side walls, as you can see. And it also selected the top surface, and we need the end mill, right? This guy here, and I use the same dimensions as the previous one, so go with 0.25 and 0.3 here. And hopefully this one will give me everything I want. Now, one thing that we need to pay attention is, look here, I have no fixture. In real life, I do have to I do have to attach this guy to the bed. And most of the time you have to use a fixture. So if you have a fixture that is raised from the bed to here or here or any place, and it's holding it, you cannot do this whole thing in one operation. Okay? It's not possible to do that. So for that reason, what you need to do is probably break this operation in half, and let's say on one side of it, then one operation do half of it, and then basically create a new operation, choose a different set of fixture, or use the CNC machine with rotating table, the 4-axis, and then get the job done. Okay, so in reality, it's not like there is no fixture. There has to be a fixture when you're doing an operation like that. So let's see if I can get what I need to have at the end of the day. And here we go, and I let you see everything. Facing is done, spot drilling is done, the entire drilling of the hole should be done. You see the holes are all the way to the bottom. And then the interior pocket, and then the external profile should be all machined. Let's see. There we go. See, here the part is made beautifully, and those 4 pieces, of course, going to be thrown away. So it's all good now, and now if you can see under my manufacturing process, I have all of the 5 operations, and these are the tools that I need to get the job done. So if I want to create this operation, if I want to do this operation over and over, I can probably create a catalog out of these tools. But again, those dimensions we just went with mostly with the dimensions from CATIA. It's not really in reality the case, and you have to go with the tools that you have at your disposal. Okay, so there is a lot more, and this is just an introduction to prismatic machining. So you see that I could generate everything now, and now it's time to create what? It's time to create CNC code or G code here. And by the way, if you want to create a part operation or create a manufacturing program, you can use these tools, 2 tools, and create more part operations and more manufacturing programs if you want, if you have more than one. And now what you need is this tool here called Generate NC Code Interactively, right? Or you can right click here, go to this object and say what? Generate NC Code Interactively. But before that, you need to go to Tools and Options. You have to go to Machining, NC Machining, go to Output, and make sure that here you select one post processor. And also, if you want G-code, you need to go here, and for the extension, you choose what? You choose the .nc, so you can generate .nc code, which is basically G-code here. Okay, so you have to first activate these. Then, as I said, you can click on this guy, and you see it chooses whatever manufacturing program that you have, and or you can select by part operations and what format of data you want. Let's say I want the NC code, and then it's gonna save it here for you under this downloads, right? And you go here to NC code, and you choose a post processor. So let's go with this one and execute. And then we can go and look at the G code. And here is the G code. Now it might issue some error like you just saw, and you have to go and fix the error. But this is the whole process of creating toolpath, creating the process, choosing the tools, selecting the speeds and so on, selecting the tool sizes, and finally generating what? G code. So hopefully this video was useful to you, and I could introduce to you the basics of prismatic machining in CATIA using a 3-axis machine. And there is a lot more that you can do with lathe machine and advanced machining and so on. But here my goal was just to introduce this quite bit lengthy and I would say hard process of defining machining operations in CATIA. Thank you so much for your attention, and I'll see you in the next video. Thanks.